We would like to learn more about how to read motion graphs. So now we want to add numbers into the mix so we can talk about what is happening more quantitatively. So in this graph, we are plotting the position over time of a bike rider. And he starts at the origin at 0 seconds, and then he rides to the right 1,200 meters. So our value of x here is 1,200 meters over 600 seconds. After that, he stops and he takes a break, and he is stationary for 400 meters. So here from 600 to 1,000, then he stays where he is, and then from 1,000 to 800 seconds. So here now he moves back to the left, and he goes back to the left, it looks like about 800 meters. So at the 1,800 second mark, he is 400 meters to the right of where he started, but then he's gone backwards, not backwards, to the left 800 meters from the direction he came from. So the point is that to start with, our bike is moving to the right, and the velocity of the bike we can find by looking at the average velocity over some period of time. So let's take this piece here, and we see that the change in position is 400 meters, and the change in time, this took 200 seconds. So it took 400, our bike traveled 400 meters in 200 seconds, so that means the velocity is 400 divided by 200, or 2 meters per second. So the slope here is positive, telling us that there's a positive velocity. Now if we look at this stop point where he's come to a stop, so here basically he's traveled 0 distance in 400 seconds, so here his average velocity is 0, and now he's turned around, and over this time period, so he has traveled 400 meters to the left in 400 seconds, so his velocity is -1 meters per second. Notice that negative velocity just means that he's moving to the left, so positive is to the right and negative is to the left. So we've been talking about cases where the velocity is constant, but we're also going to want to consider the case of constant acceleration where the velocity is changing. In this graph, we are looking at position versus time again. Notice it says x on the y-axis, so that tells us that we are looking at, we are talking about the position to the left and right, the x direction in this graph. So at the beginning here, our object is at the origin, and to find the velocity, we look at the slope. So to start with, the slope looks pretty close to 0, so the object is stationary at the very start. However, this slope is becoming more and more positive, and by the time we get to 1 second, there is very clearly a positive slope here. So that means that the object is moving to the right, and the slope is increasing, so that means that the velocity to the right is increasing with time. And if we continue this, if we look at the slope here and the slope here, I drew that poorly, but the slope is steadily increasing as a function of time. That means the object is moving to the right, and it's going faster and faster to the right as time goes on. If we want to look at this more quantitatively, we can find the average velocity for the different time periods. So from 0 to 1 second, here we traveled 1 meter in 1 second, so the average velocity over this time period is 1 meter per second. In the 1 to 2 second region, so this one's done for us, we traveled 3 meters, so we went from 1 meter to 4 meters, so the change in position is 3 meters. It took 1 second to do this, and so that means that the average velocity is 3 meters per second. And if we go to 2 to 3 seconds, here our change in position is 9 minus 4. We traveled from 4 to 9, so we traveled 5 to the right, and then that happened in 1 second. So there, the average velocity from 2 to 3 is 5 meters per second. So that means that the average velocity went from 1 meter per second to 3 meters per second to 5 meters per second, and it is very clearly increasing. So that means we are looking at acceleration. So we're also going to want to figure out the velocity at a particular time and not just the average velocity. So this is kind of like the speedometer in your car. It tells you how fast you're going at that instant, and we'd like to know the velocity of the object at that instant. So how do we do this without calculus? Well, if you do know calculus, The slope of the line is the derivative, so you can find that slope using the derivative. So what we're going to do is to find the slope by shrinking down the graph and finding the slope of the tangent line. So the idea here is that if we make a smaller and smaller area here, we can just kind of draw a straight line here that is parallel to the graph, and then we can treat that as the slope at that instant, and then we can find the slope of that line. So if we, I don't know, just karate chopped it or just put a ruler on the graph and lined it up at that point, then drew the line, then it's kind of lazy strategy here, but it gives us at least a qualitative idea on what that slope is. So we can get the idea for what the velocity is at a given time. And as far as it goes for the moment, what we're really focused on is whether the object is moving to the right or the left, or whether it's stationary. So for that, we really just need a sort of intuitive look at this. So you have a few questions like this one to do. So we want to know whether the object is moving to the right, to the left, or if it's stationary at a certain time. And so that means if the slope is positive, it's moving to the right. If the slope is negative, it's moving to the left. And if the slope is 0, then that means the velocity, the instantaneous velocity, is 0. So we have a curve here. Let's start at point 4 here. And so here the slope is clearly negative. So that tells us that the object is moving to the left. If we look at point 5, the slope is still negative. 6, it's still negative. So that means through 4, 5, and 6, our object is moving to the left. So as we get to point 7, and if we draw our tangent line here, it certainly looks like at this point the slope has gone to 0. So our object has been moving to the left, but it's starting to come to a stop, and then it comes to a stop right at the origin at point 7. So the slope here is 0, and that means that the velocity at this point is 0. Our object is stationary. As we go to points 8 and 9, the slope is now positive, so the object is moving to the right. So the key is, if we want to know the direction of the motion, and we're looking at a position versus time graph, then we want to look at the slope. That tells us the velocity, and it means we know the direction of the motion. People are going to be tempted to look at the position, so the fact that you're above the origin, all that tells you is that you're to the right of the origin. You have to look at the slope to figure out what the direction of the motion is. So here's another example of a question like this one. So again, you're going to focus on the slope of the graph to find out the direction of the motion. If the slope is positive, the velocity is positive, and the object is moving to the right. If the slope is 0, then the velocity is 0, and your object is stationary. And if the slope is negative, then the object is moving to the left, and the velocity is negative. If you have the position versus time, basically the slope is what's telling you the direction and how fast that object is moving. So you have one more question. This time we give you the position versus time graph, and you need to pick the correct velocity versus time graph. So that means if we examine this position graph, it tells out that at the beginning here, our slope here is pretty much 0. So that means, well, what does that tell us about the velocity? And then as we move further in time, now the slope is negative. Yikes. The slope is negative, and so that means our object is moving to the left here. So what does that tell us about the velocity? And notice that this slope is becoming a larger and larger negative value, so that's telling us that the velocity is changing, and it's telling us how that velocity should be changing. So we've got 3 options here, so you get to figure out which of these graphs gives the appropriate velocity graph for this position versus time graph. Alright, so I'm going to let you guys answer some questions, then we're going to do one more short bit on acceleration. Good luck.